Hi, this is Connected Devices at Scale, a deep dive into the AWS Smart Product Solution. I'm Steve Blackwell, the worldwide tech leader for manufacturing, and with me today I have Bamsat Lee, the solution builder from AWS Solutions team. So what we're going to talk through today is why and what is a smart product, and then we're going to go into our smart product solution and give you an introduction into that. Give you an overview of the key features of our smart product solution, how you can customize our smart product solution, and then give you a demo of how it works. What will you learn today? So you'll understand the best practices of designing connected devices, key features of smart product solutions, and learn how to customize our smart product solution for your particular use cases. So let's get into it before I hand over to Bamsak to give you an overview, or more to the point, why and what is a smart product. Within the manufacturing industry, there are some key trends. Some people call it Industry 4.0, others call it digital manufacturing. But the key thing that I want to talk about today is within that we have products as a service, connected products, and data, and actually having that data from your smart products and bringing it back into your manufacturing ecosystem, hence what a smart product is. So as part of this narrative, in AWS, we have created the manufacturing reference architecture. And what we're going to focus on today is the right-hand side, the connected products. But the reason why I bring this up and showing you this architecture is one of the key points around a smart product is the data that we can actually take from those smart products and connected products and bring it back into the manufacturing value chain so that we can actually link that together. So we call this the manufacturing flywheel, where we have the designing of new products and introductions of those products flowing into the factory manufacturing of those products that then goes through to the products actually out in the field, and the information that you can collect for those products then feeds back through into new iterations of the product or new products themselves based on field analytics and usage. So now I want to talk about some smart product use cases, and I'm going to do this through talking about 3 of our customers that are running smart products on AWS. The first one is Valmet, who manufacture paper mills. These are large machines that create paper, from toilet paper through to cardboard, as an example. And they've connected their machines to get equipment and process manufacturing data so they can start to build digital twins and actually provide analytics to improve the paper quality and reduce unplanned downtime of their customers that use their machines. The second customer I want to talk about is iRobot, who manufacture robot vacuum cleaners, and they've got their products connected, getting the data from how their robots are being used so that they actually can create an ecosystem of smart homes. And the final customer I want to talk about is SKF, who have created a system called Connected System 24 for their customers, which provides smart lubrication to their large ball bearings that are running out in fields in mining machines and wind turbines. And through this, they can actually reduce the amount of maintenance that needs to be done by humans, by the ball bearings actually lubricating themselves. And then they can also get field analytics information and usage information of how those ball bearings are actually operating out in the field to drive insight to their customers and actually to feed back into their manufacturing and design process, as I talked about earlier on in the manufacturing flywheel. But all of this 3 use cases have to have an underlying platform that actually enables those smart products, and that's through providing fleet management, just-in-time deployment of those products, having secure connectivity not only on the product itself, but ingesting the data, sending the data down between the product and actually within the backend systems running on the cloud. And then once we've actually got that there, what can we actually do with that data and using analytics and machine learning to bring intelligence back into your business, but also providing additional functions and features to your end customers. So now at this point, I'm going to hand over to Bamsak, who's actually going to go into the specifics of our smart product solution.
Thanks, Steve. And hi, my name is Bamsak Lee, and I'm a solutions builder of Smart Product Solution. From now, I'm going to introduce Smart Product Solution, and I'm going to talk about the architecture decision point we made. So, what is the Smart Product Solution? The Smart Product Solution is a deployable reference architecture which is demonstrating the art of possible and enabling manufacturers to jumpstart development of innovative smart product services. Using the Smart Product Solution, manufacturers can rapidly deploy and build upon an open source architecture to enable smart product applications by converting valuable information from the real world into digital data that provides increased visibility to businesses of how users interact their products or services. By default, the smart product solution has been built based on HVAC devices, but customers can customize it easily. With the smart product solution, customers can see the status of connected devices and control devices remotely. So when customers want to build a solution to control devices remotely and see the device status remotely, they can think of adopting smart product solution. In addition, the smart product solution collects telemetry, alerts, and diagnostic information of connected devices, and users of the smart product solution can get the alarms from the smart product solution. Now, let's see some key features of smart product solution. This is the overall architecture of the smart product solution. The smart product solution is designed to connect HVAC devices with AWS IoT Greengrass Core or IoT Device SDK. Either way, customers can choose which to use to connect to the solution. The supported protocols to connect to AWS IoT Core are MQTT and HTTPS. For the demo purpose, Smart Product Solution is going to use MQTT with X.509 client certificate. The features of the Smart Product Solution are just-in-time registration, event message proxy service, remote command service, telemetry analytics pipeline with AWS IoT Analytics, device defender, and API service for the owner web console. The web console can be used by the device owners to manage their smart devices. Later, I'm going to show the owner web console demo. Please note that the owner web console is only for the demo purpose, so we don't recommend using this one directly into your production environment because it only supports minimized features to manage smart devices. As you can see the overall architecture, every component is serverless. The biggest reason to build it completely serverless is that we would like customers to free from managing infrastructure resources such as EC2 instances. As a result, customers only can focus on the development area with the serverless architecture. Let's start from the onboarding part. Every device needs to be registered into the solution before connecting to the solution. To register device, customers can choose just-in-time registration or just-in-time provisioning. Just-in-time registration needs to create an IoT rule and a Lambda function, whereas just-in-time provisioning requires template body attaching to CA certificate. Both of them are going to be triggered when a new device with unregistered certificate tries to connect to AWS IoT Core. Even though just-in-time provisioning has fewer steps than just-in-time registration, and just-in-time provisioning actually provisions a thing in AWS IoT Core, the smart product solution is using just-in-time registration because it requires some additional customized steps to finish the device registration by the Lambda function. Among the overall architecture, these are the resources that are used during the just-in-time registration: AWS IoT Core, just-in-time registration Lambda function, DynamoDB table, Smart Product API, and Owner Web Console are going to be used for the device registration. The device registration is going to be started from the Owner Web Console. When a user wants to register a device, the user needs serial number and model number from the manufacturer. When you think of real IoT devices, you would see serial number, which is typically attached on the device. Likewise, the smart product solution requires serial number and model number, and the manufacturer can define serial numbers, model number, and the device detail specification in the reference table. Serial number would become the AWS IoT thing name, so it should be unique. Smart product solution has a thing type whose attributes are the user ID, the model number, and the device name, and they will be the searchable attributes. Customers can put more attributes to thing type, but thing type only can contain 3 searchable attributes, so the other attributes are not able to be searched by the split index. When user clicks register button, the device is going to be registered into registration table. After that, user is going to connect the actual device to the smart product solution. The smart product solution is going to provide the steps to create certificate and trigger just-in-time registration process. But maybe in the real world, users don't have to follow these steps because manufacturers are basically going to do this once. The actual users don't care about certificate related stuff. Users might only need to follow the registration steps provided by manufacturers. Back to the smart product solution, when a device with unregistered certificate, which is created with the registered CA certificate, connects to AWS IoT Core, one of AWS reserved topic on the screen will get a message which says certificate registered. Then IoT rule engine is going to send the message to just-in-time registration Lambda function. Once Lambda function gets the event message, Lambda function is going to create IoT policy, attach the policy to the device certificate, and attach the device certificate to the thing. Just-in-time registration Lambda function is going to determine the thing name with the common name in the device certificate. So the common name needs to be provided to the device certificate. When everything is done, the Lambda function updates the device status. After the registration, the device, which is a thing in AWS IoT Core, will have these IoT policies. These are the demo purpose, but we try to minimize the IoT policy as little as possible. If customers want to change the policy, they can change the policies to what they wish to have. The Smart Product solution provides permission to connect to IoT Core, get thing shadow, update thing shadow, publish messages to topics, subscribe topics, and receive messages from topics. Next, when the registration is done, the device can send events. So let me introduce how event message proxy service on the Smart Product solution works. For the event message proxy service, AWS IoT Core, Lambda functions, DynamoDB tables, and Amazon's simple notification service are going to be used. Owner Web Console is for seeing the events happened on devices. All serverless and customers can easily customize them. When we built this solution, AWS IoT events had not been generally available. That is why we chose to use Lambda functions to deal with events to give flexibility to build the solution. But later, maybe customers could think of adopting AWS IoT events for device events. There are two event categories at the Smart Product solution. One is event history, and the other one is event alerts. Event history is for the whole historical events generated by full registered devices. The solution supports error, warning, info, and diagnostic level events, but users can customize the event level. Event alerts are a subset of event history, but it only shows certain events with the configured levels by users. Once the user reads the event, it will not show on the UI, so users can track the unread alerts only. On the owner web console, it looks like this. Event history shows every event, but if user sets the preferable alert level to error, event alerts only shows error events. The event message proxy service workflow starts from the device. Maybe manufacturers or device users can set the event message in devices so devices can send events to the AWS IoT Core. When a device publishes event message to the event topic, the rule engine sends the message to event message proxy Lambda function. The Lambda function saves the raw data into event table, so maybe the raw data format needs to be defined by users. The Smart Product solution has predefined event format, but customers can change the format. After inserting the event into the event table, the Lambda function sends the event to notification service Lambda function. The notification Lambda function is going to check the user alert configuration, which is in setting table. Then when event messages alert level is in the user's configuration, the Lambda function is going to send SMS message through the Amazon SNS topic. Users can set to get SMS messages or not as well. In the notification service, customers also can set the threshold to send a notification. For example, if the temperature is above certain value, they can send a notification. Also, customers can change the method to get notification by customizing the solution. If there are a lot of event messages, customers can put Amazon Simple Queue service or Amazon Kinesis between IoT rule and the event message proxy Lambda function to give more buffers so that the Lambda function cannot be throttled. If you want Lambda function to handle more concurrency, you can request limit increase at AWS Support Center, but giving buffers would be always the better option. Last feature that I'm going to talk about is the telemetry analytics pipeline on the smart product solution. The smart products uses AWS IoT analytics for the telemetry data, and customers can integrate Amazon Quicksight to visualize the data from AWS IoT analytics. These are possible services that customers can choose to analyze IoT telemetry data. The smart product solution is using AWS IoT analytics because it is designed specifically for IoT. It supports storage of time series data and device-specific data enrichment. It also supports to query on large data sets and predictive fleet maintenance with Amazon SageMaker and AWS IoT Greengrass. But if customers want to see the real-time processing data, they can choose Amazon Kinesis Data Analytics instead of AWS IoT Analytics because AWS IoT Analytics does not support real-time processing data. If they want to build the telemetry analytics solution by themselves, they might choose Amazon Simple Storage Service. When telemetry message comes to AWS IoT Core through the telemetry topic, the rule engine sends it to AWS IoT Analytics channel, then the channel sends the message to pipeline. The pipeline is going to convert temperature and time with telemetry Lambda function, then it stores the converted data into data store. Dataset can retrieve data from data store with a simple SQL. For the pipeline activity, customers simply can transform the data with a simple formula. The smart product solution added the telemetry Lambda function, which converts temperature from Fahrenheit to Celsius and time to UTC time with the timestamp for the demo purpose. So it requires certain JSON format like the left one. Once again, customers can add more functions to enrich their telemetry data. To visualize the telemetry data, customers can integrate Amazon Quicksight. By default, the smart product does not provide Amazon Quicksight provisioning due to the restriction of Amazon CloudFormation. However, customers can easily create a visualized dashboard at Amazon Quicksight. They can create a new dataset from AWS IoT Analytics, then they can make graphs whichever they want. Now, it's time to talk about the customization. I've said that customer can customize the solution easily, and this is how. The Smart Product solution provides CI/CD pipeline with AWS Cloud Development Kit. When customer provisions the solution creates the CI/CD pipeline. When customer changes anything, including infrastructure provisioning with AWS Cloud Development Kit, CI/CD pipeline is going to be triggered automatically, and the pipeline builds and deploys the new version of code to customer's solution. Then customers can have their own smart product solution. What customers need to do is cloning the code commit repository and make a change. Customers can connect to the repository by uploading SSH public key to IAM user or creating Git credentials for IAM user. The Smart Product solution uses a manifest file for AWS Cloud Development Kit, and it will be generated according to parameters which customers set during the deployment of the solution. Customer can choose to deploy API infrastructure, Defender infrastructure, event infrastructure, just-in-time registration infrastructure, owner web console infrastructure, and telemetry infrastructure. If customer would like to change the event or telemetry topic, or remove or put more infrastructure into the solution, they can modify the source code in the Smart Product Solution CI/CD pipeline. When customers change Lambda function source code, they need to change the solution version parameter so that Lambda functions can get the new source code. So from now, I'm going to show the demo UI of the Smart Product solution. When customer launch the solution, it will create 3 CloudFormation stacks. One is created by customers dealing with the CI/CD pipeline. Another one is for the CDK toolkit to have the CloudFormation template for actual resources of the Smart Product solution. And the other one is the actual resources created by CDK. When customer choose Smart Product Solution stack, the customer can see the owner web console URL at the output tab. When I click the URL, it will show the Smart Product Solution owner web console. Once again, the demo UI is for the demo purpose, so we highly recommend to use your own web console. At the first time, customers need to create account. After creating and verifying the account, they can sign into the web console. Every user authentication process is provided by AWS Amplify. On the main page, it shows registered devices and brief information of the devices. Top alerts are for the event alerts, and it refreshes every 5 minutes. Let's start from the registration. Clicking register a device button shows the device registration page. Like I said before, serial number and model number are needed. So go to the reference DynamoDB table, which needs to be filled by the manufacturers, and choose one device ID, which is serial number and model number. In the real world, these would be tagged on the device. Then let's register a device. So going to the console and put serial number, model number, and device name and register. Once it's done on the UI side, it provides how to register the certificate and trigger just-in-time registration. In the real world, this command line is not needed on the user side. I'm going to just finish the step. Then the device status is still pending because I haven't triggered just-in-time registration. Let's assume that an EC2 instance acts like an IoT device. I've created a script to create certificate and register the certificate to IoT core. So let's run it. And it will also start the demo simulator with AWS IoT device SDK. And the demo simulator is going to publish telemetry data to telemetry topic every 10 seconds. So going back to the owner web console, when I refresh the page, we can see that the status has been changed to complete. And going to main page, it says the device is connected to AWS IoT core. Then we can see the device state sent by the device on the device detail page. Going to the command tabs, I can execute the remote command to the device. Right now, it's supposed to change the power status and target temperature. If I click heat button, the device is going to turn on the heat as it gets the message from the UI. So see it, then the device gets the message. So you can see the message from the UI at the device side as well. So going back to the console, if I change the target temperature, the device is going to get the message from the UI again. I configured to publish warning or error event based on the gap between actual temperature and the target temperature for the demo purpose. So the device starts to publish warning events. I can see the command detail and the event log of the device. The event log is only for this device. If I go to event history, I can see the whole events of my devices. And when I go to event alert, instead of these event histories, I will only can see events based on my configuration. So let's go to event alerts. Event alert only shows the event configured by the user. So to change the configuration, I will choose user setting, then change the alert profile preference level to info. After that, event alert page only shows info level events. When I refresh the page, the number of alerts is reduced as I set info level only. So refresh the page and the alert became 10. When I read the event, it shows the event detail and the event will be gone from the UI and the number of alerts is also reduced again. So when I refresh the page, it shows that my alerts are 7. So going to the main page, I can delete the device. So before deleting the device, I'm going to stop the device simulator. So stopping this one. And when I click delete button, it will delete the device from the UI and AWS IoT core. For the telemetry data, I can integrate Amazon Quicksight. So going to Quicksight. So click new analysis and click new dataset. I can choose AWS IoT Analytics. Then it shows smart product dataset. When I create data source, it will create the data source, but I created one in advance, so I'm going to choose cancel. After creating the dataset, I can create a visualized dashboard with the dataset, and customers also can create and customize their telemetry data to analyze with Amazon Quicksight. Okay, let's wrap up. During the session, you might learn the best practice design for connected devices with the smart product solution and some key features of smart product solution to adapt into your environment and how to customize smart product solution to make it fit into your production environment. After the session, you can see more resources on this website. Thank you very much for attending this webinar, and I hope you've learned about smart product solution. Have a nice day.